Welcome to the Zeffeldar Programming Tutorial Series, Episode 2. This series is intended for people who are interested in programming on the Commodore 64, and it is of a technical nature. Zeffeldar was a game concept that my friends and I came up with a long time ago, but we never completed. It was going to be sort of an Ultima style of game. So I thought it would be fun to do a tutorial series on some of the programming pieces and parts that would be required to produce such a game. In episode 1, I covered the programming required to create a game map and display a portion of it on the screen, while accepting user input to scroll or navigate through the game's map. In this episode, I mostly cover creating an animated water effect using the Commodore 64 program interrupt, as well as a few other interesting tidbits. So let's jump into it. Alright, I wanted to thank everyone for all of their suggestions and their kindness after the release of the last video. I did hear back from the Oldskoolcoder who came up with an idea to make a small improvement to the program. And, it was something that I should have thought of, but just in the heat of getting the program out, I didn't. So, and I'm glad that he contacted me, and I'm going to share that with you here. So, what it is, it revolves around the game map right here, and how I just kind of hard-coded the game map location at $2000, and he was saying you don't really have to do that, and I agree, and I've coded other programs this way before, but he was saying all you have to do is go in here and label your game map data. So you can go in here and put the low byte of the game map and then the high byte of the game map, and then just follow that along, and we can do game map 0, game map 1, all the way down until the end, and then just fill these in so they're not hard-coded values. And I'm just going to compile and run that. And so that works beautifully, and it's a terrific suggestion, and one that I am going to implement here shortly. So thank you for that, Oldskoolcoder, and thank you for your suggestion. Alright, so here I am. I'm halfway into implementing Mr. Oldskoolcoder's changes. I have game map 0, 1 through 9 down here, and on the lower bytes I have all of them mapped out less than game map 0, game map 1, all the way through less than game map 9. And I'm simply going to copy this line right here and change all of the less than signs to greater than signs for the second part. And then once I've done this, we no longer need to use that the address 2000 down there, and the map data can be anywhere in memory. So this line right here can be stripped. And let's test it out. Alright, oh, yeah, of course, game map 0. This is a problem. Leave. So thank you for that again, and it was a terrific suggestion, and now let's move on to the next segment. Alright, I'm looking at the Commodore Memory Map, the Commodore 64 Memory Map, and I'm looking at positions hexadecimal 314 and 315. This is the address that you need to modify in order to set your interrupt, at least one of the ways to set a program interrupt, which I'm going to demonstrate right here. Let's add a new file, interrupt, and we'll start from scratch. We'll set the program address to be at 1000, and we'll have an interrupt section down here. We'll call it interrupt. And what we'll do, the first thing we'll do is we'll load the low value of interrupt and store it at 314, and then we'll load the high value of interrupt and store it at 315. Now, of course, before we do this, we have to turn off the program interrupts and then turn back on the program interrupt. And let's see, we need the number sign in front, so we want the value of the interrupt. And in the interrupt code, see, right here we're just going to return back RTS. And in the interrupt code, in order to determine if it's running something, what I'm going to do is just increment the value at position 400, excuse me. And then the instruction to return it back to the regular program code is to jump to address EA31. So if we run this, it should increment the value at 400 just continuously as a background process. So let's watch that. Let's execute it, 4096. And so now you can see it's running continuously, incrementing that in the background. So a couple of highlights here for this particular program demo is this is the start address, which is 1000 hexadecimal, 4096 decimal. You do need the number sign in front of the label here. Without it, let's see what happens. You get the CPU jam. So to kind of explain the difference between the hashtag being there and not being there, if you were to say LDA FA, that's saying load the memory address location FA into the accumulator. So whatever is stored at the address contained at the position FA in memory, it's going to load that into the accumulator. Now if you put a hashtag in front of it or a pound sign, that's saying load, literally load the number FA, not the address, but the number. So FA would be loaded into memory and then stored. So it's two different results. It's kind of hard to explain, but that's the difference. This loads it literally from that address if you don't have the hashtag, and then this loads the literal number or the actual hexadecimal value into memory as opposed to what's stored at the memory location. So anyhow, that's the difference, and that's why you need the hashtag on there. And this is a short little program that runs in the program interrupt. Once you execute it, it just increments what's at 400. Now, if I wanted to slow that down, how I've been doing it, and you'll see it here in my demo, my next demo. But all I am doing to slow it down is to load a variable, like load, and I called it value. And I have a byte down here. Value byte 00. So I'm saying load value, increment value first, load value, compare it to a number like 20. If it's not equal to 20, then we want to jump back. We want it to go back to the program execution. Otherwise, if you do hit that 20th one, we want to reset the value. So load a 0, store it in value, and then do the interrupt portion that you're going to do in the interrupt. So let's run this. That should slow down significantly that program from running. Watch, you'll see. So now it's a lot slower. And that's how I slow things down in the program interrupt. Just by adjusting this comparison here, you can speed it up or slow it down. So it can double the speed by changing that number. See? And if you strip it out completely, it'll be at full speed. Alright, that's my segment on program interrupts, and in the next segment I'll put that into use. Alright, in this segment I want to cover a couple of items, and the first is redefining the character set. And then the second part of this is shifting characters within the character set to create a kind of an animation. And we wanted that animation to bring the water to life in this demo here. So first off, I want to acknowledge that I copied this source code here from the website, thedustlayer.com, and it's a terrific website, and there's a great explanation here. And then within it there's some sample code which I've copied, and I've tweaked it a little bit so that I could use it in my program here. And so you can see here from this portion, from here to here, I essentially just copied it from DustLayer. About the only modification that I made was that I decided to copy the character set from ROM into RAM and just change the location into RAM where it was stored. I stored it at location 3000, hexadecimal 3000. So that's what this program here is doing. It's copying ROM, all of the character sets in the Commodore 64's memory, all the characters from ROM into RAM, stuffing them at position 3000. And then directly following copying all of the character set, all of the characters from ROM to RAM, I have a quick little interrupt program here that all it's doing is shifting the very first character, which starts at position 3000. So the first 8 bytes starting at 3000 is the first character in the Commodore ASCII character set, and that first character is an @ sign. And what I'm doing here is I'm shifting it. So I'm loading the first byte, the second byte, storing it as the first. I'm loading the third, storing it in the second position. Loading the third or fourth, storing it in the third, and so on, all the way down the line. And so that creates a shift. And then there is a sort of a delay here. There's a variable that I have called value. And so I'm only doing that shift every 10 times. So every time this variable gets set to 10, we set it back to 0, and then I do the shift. And so from this part down to here is the shift. And so let's run that, and I'll show you what I'm talking about. So you see on the top left here, that's the @ key, or the @ character. And it's running in the interrupt, so while, we could do other things here while that's running. It's sort of like a background process. Now, what I wanted to do after I successfully did this portion was to come up with some sort of a character that would look like water. So in order to do that, what we have to do is come up here and go into the character editor. In the character editor, you can play around with your characters here and draw things to be the way you want them to be. So I'm going to clear this. And what I was trying to do is come up with something that when you shift it would look like water. So you can kind of see what it would look like just by shifting up or down. And then when you get one you like, I was coming up here to character set, export to preview, and then I was coming down here and generating just the range of characters. I was doing 0 to 1, make it hex. Oops. And then I was copying this line. So I was copying this whole line. The first one is the first byte. And I haven't saved it. Down at the bottom, of the program, I have a few samples that I've already played with. So let's take a look from the beginning to the end here. So I have a variable down here called water, and there's 8 bytes. And what I want to do is copy these 8 bytes and replace them in starting at position 3000. And so to do that, I just going to do a quick loop here. Load the X register with the 0. Load water, comma X. Store it, position 3000, comma X. Increment X by 1. Compare X to number 8. Branch if not equal to loop. So you want it to loop, and we're gonna put a loop variable here. The @ sign in front of the word loop is just, it's a CBM, Program Studio way of defining the scope, is just local to this program. So you could use, like here I'm using without the @ sign, but you could use it multiple times, that same variable, if you use the @ sign. And then the ones without the @ sign are globally defined variables. But anyway, I'm sidetracked. Let's run it now with the program in place and see what the character that I came up looks like. Now on this one, I don't like this one in particular because you can't tell if it's shifting up or down. You could kind of see where it could be water, but I don't really like that one so much. I would like it to where when it's running, you could distinguish whether or not it's moving up or down. So let's look at the second one that I came up with. And this is the same issue here. Although I think this one's a little better. You still can't tell if the water is shifting up or down. So let's look at the third one. Some of these are just shots in the dark. And then this one I don't like. It doesn't look like water. But you can kind of tell it's shifting up. It's shifting up, which was what I was going for. Let's go to the next one. Oh, okay, yeah, on this one I don't really like. It looks like a bat. To me, it looks like a adventure bat or something. The way they coded the animation. So I don't like that one. And then the next one I kind of like. I think it could work with some minor modifications. You kind of see how that looks, how you can see it shifting up. And then I kind of went and looked at how Ultima 1 looks. And I came up with my final choice. Which is more like this. I'm not really 100% satisfied with this one either, but that's how they coded Ultima 1. Something like this. You can tell it's shifting, which direction it's shifting in. And if we decided to, we could change the order of the shift by modifying this code. Instead of storing it, from position 7 to 6, we go 6 to 7, 5 to 6, 4, and so on. Okay, so now that we have some sort of a water character defined, the next step would be to copy this code here and combine it with the other code that I've already developed. So let's do that next. So before doing that, I don't want to modify this one anymore, just for historical purposes. The Zef2 is what I'm referring to. What I'll do is make a copy of this, and just do a new one and call it ZEF3. Paste in that code, and then I'll copy the code from the little demo that I was just showing off, and we'll have to combine that with ZEF3 some kind of way. Throw it down here at the bottom, and then I'll have to make some changes to make this work. Okay, I think that's it. I just gotta call it. So after we clear the screen and before the main loop, call it out to the subroutine. The only other thing we need to do here is, I'm thinking instead of the minus signs, we put the at signs there. And let's see if it compiles first try. Lucky. All right, there it is. There's the water and the shifting. Yeah. I don't know. I think I like the second to the last one better than this one. Let's see what it looks like with the one I'm just now referring to. I think I like this one. As crazy as it sounds, I think I like it a little better. Let's see. Oh, it's kind of busy. Yeah. All right. Well, I'm going to continue. If anyone has any ideas on how to define the water, send me an email. I really would like to hear it. Yeah, I'll switch it back to the other one for now. Oops. Oh, I hit Q. Q quits the program. Yeah, I'll switch it back. All right, I'm happy with it. All right, now that we have the beginnings of something that looks like a little bit like it could be forming into a game, I think the next step, it would be fun to sort of draw it out in the screen designer, how you would want it to look. Maybe put a border around this. Maybe you could, if you wanted to, move this to draw it in the middle somewhere. But that's totally up to your imagination and how you would like to design it. And it's completely, there's no wrong solution here. So let's go ahead and try that now in the screen designer. Now in the program, the screen width here is 15 by 10. So if you do move it, there's a few things you'll have to do if you move the position, at least within the way I've designed the program. If you move it or if you change the width, you have to adjust these variables in here. And then also these positions have to get updated. So just like the Oldskoolcoder suggested, we'll have to go in and do something similar to this that we did in the previous segment if we move that position. Now the only difference is I probably would go to 2-letter variable to keep this shorter instead of having a big long description here for each line going across, for each byte. Alright, so let's go into the tools, screen editor, And if we count out 15 across, it's about right here. So we can go in under reverse characters. It doesn't have to be reverse, but we can look at corner characters or whatever you wanted to put in here. And this is a part actually that could end up taking more time, more time than you would think, right? To design this to look exactly how you would want. And you could take inspiration from games like the Ultima or games similar to that. And you would need a spot somewhere where you have, where you can enter commands like to go north, north, south, up, down, left, right, and then maybe some boxes over here. However you want to design it. So like here, I think we would do a corner character. Now, if you pick the wrong character here, you'll end up with a border here that doesn't have anything in it. So you want it to be snug. So I know these are the wrong characters here. But you get the idea. So this is the hard part. This is one of the hard parts is in game design is getting the entire screen designed exactly the way that makes the most sense. So I'm gonna do a mock-up offline here, and we'll come back.